Welcome to the vendor track. This is the second talk of the day for Chef Workstation on Azure. My name's Tom Bevan. I'm with the Devops group. We've got 45 minutes, so we're going to have about 5 minutes at the end for Q&A. Really excited to welcome Stuart Preston to the stage, the guy that literally wrote using Chef in Azure. Stu's in the product engineering team, working with and developing the Microsoft products for the Microsoft ecosystem, PowerShell, Azure, Devops, or VSTS, Windows, and on the Azure platform. So I'll get out of the way. Stu, over to you.
Thank you. All right. Hello, everyone. Am I on? Yes. So this is Chef Workstation on. I keep calling it Azure, and I forget that I'm in the UK. And I am British, and I can say Azure here, and people know what I'm talking about. It's brilliant. All right, we're going to talk just a little bit about Chef and kind of Chef's overall roadmap and kind of where the Chef kind of tooling fits in. Talk about history of Chef on kind of Windows and where our engineering focus is for 2019, as we're getting now sort of into the sort of period of the year where there's holidays happening and everyone's planning next year. And then I'll try and get into some demos. Feel free to interrupt me at sort of any time, basically, and ask questions. Okay, so who here is using Chef in their environments today? Okay, we've got a handful of people, excellent. So to those people, this kind of view of the world is probably familiar because you probably get given the emails about it very frequently. This is kind of our portfolio of products. Chef is kind of Chef software has three main kind of streams to it. So there's Chef, the product, which is dealing with infrastructure automation. There's Inspec, which came to us through an acquisition about 2 years ago, which is focused on compliance automation. And then we've got Habitat, which is focused on the application automation side of things. And those products are they're open source, and you can go and contribute to them. We then also have a commercial product called Chef Automate. That's the thing that we want enterprises to subscribe to. So if you're looking for commercial software, kind of come and talk to us about that. If you want to talk to us about open source software, come and talk to us on the booth about that, and we can give you a lot more kind of detail about this. But this session is going to be focused on sort of Chef and Windows and the Azure side of things, which is kind of where I spend my time. Over the years, so Chef's been around 10 years, just kind of celebrated our sort of 10th anniversary this year. And over that time, we've had contributions from kind of all over the ecosystem. So people have added things like, we started obviously in configuration management, infrastructure automation, and people have added service discovery and provisioning tools. We had a tool ourselves called Chef Provisioning at a certain time. There's scheduling's come along, clustering. There's dependency verification and secrets management. We added our own tools like Chef Vault, but actually what we're focusing on in Chef's roadmap is configuration management, and we really want people to be to use Chef for configuration management and only for configuration management. And for all these other things, you've got choices. Some of those you will come to our tooling for. So for service discovery and clustering and dependency verification, and you might come to our Habitat tool. For provisioning, you might use your own provisioning tool. Terraform is pretty popular, I understand. And obviously in Azure, you've got ARM templates, and AWS, you have cloud formation and so on. So that's really our focus on the infrastructure side of things. On the application side of things, if you don't know about Habitat, I'd recommend you go and sort of check it out. It's kind of our way of declaratively specifying what the dependencies are for your applications so that you can introduce this tooling into a continuous kind of life cycle of application delivery rather than the infrastructure side of things. And we're deliberately trying to sort of separate out those two ecosystems. But we're going to talk about the Chef ecosystem, and specifically the Windows ecosystem. The history of kind of Chef and Windows. Chef has supported Windows for a long time with built-in resources inside Chef itself. So Chef being a system that manages the policy on machines. So it's not like an orchestrator. It is literally a tool that you run periodically to manage policy on a system. And the ecosystem has brought us application cookbooks and IIS cookbooks and PowerShell cookbooks, and people who want to configure WSUS on their system wrote a WSUS client cookbook. And people who wrote Chocolatey contributed the Chocolatey cookbook. And cookbooks are payload in Chef. They're kind of libraries of utilities that you kind of include together and you wrap in your own cookbooks, and you can define roles and environments to enact a kind of a complete process going through that system. But Chef itself has always had some support for Windows in the form of you could write recipes. That recipes are the inner sort of loop within a cookbook. Within Chef itself, we have PowerShell script resources. We have resources to access DSC, and we had a small number of Windows resources to do things like managing the task scheduler and stopping and starting services and so on. But our vision for Chef, and sort of those of you working with Chef probably seen the progression over time, is that we talk now kind of more batteries included, and we really want to get to a place where those cookbooks are kind of not necessary from the ecosystem. They've kind of been contributed over time. Some of them have kind of got a bit stale. We're not getting the feedback that we once got for those cookbooks. So we're interested in bringing in those resources inside Chef. And so Chef 14, which is the current version, we've delivered on that promise and sort of brought in all the Chocolatey resources we can. We've brought in some of the Windows resources, and we're still kind of on that journey. And bringing in resources from the PowerShell side of things. And then we expect over time, as kind of people get more into the application automation side of things, that the things like the IIS cookbook and application-specific cookbooks will actually go into our Habitat ecosystem. So probably the things you see at the top here might actually fall away in the end. When you look at the Chef ecosystem as a whole, Chef historically has sort of aimed, over at this managed kind of optimized area, which is kind of really where we train people. People who came to us to learn Chef, we would try and take them on this journey that got them to this managed world. And the feedback we were getting specifically was, that Chef's hard to get started with. How can I, help get started? And so we have this thing called Chef Workstation, which is a product we announced earlier this year. And where it fits in this ecosystem is it brings together some of the tools that you already know if you're developing with Chef in the Chef development kit, or Chef DK as we call it, and adds some tooling so that you can start working with Chef very quickly, kind of out of the gate. There is a little arrow there pointing to ad hoc. So Chef Workstation, the easiest way to get started with Chef, does replace the Chef DK. Future versions of Chef DK will just kind of fall away and be replaced by Chef Workstation. You install Chef Workstation on your client, and client has then all the tools that are needed to deal with the testing side of Chef and all the sort of development artifacts interacting with the server, so tools like Knife, if you're familiar with our Chef toolset, are in there. We also want Chef Workstation to be auto-updating, so there's actually an auto-updater that comes with it now. You can switch between our stable channel of Chef Workstation or the current channel, so that on the current channel there might be 2 or 3 builds a day sort of going through there as different dependencies of the whole ecosystem kind of work their way through, whether that's just security patches or just latest versions of the Chef client that we embed inside the Chef Workstation. But the whole project is free and open source, and there's reference to GitHub there if you want to go and look at some issues or contribute to it. Now, the ad hoc mode within Chef Workstation is basically powered by this command we've developed called chef run. And chef run is a way of executing commands on a target node remotely in an ad hoc manner. And so so you can take chef run, point it at a machine over SSH or WinRM. You can use any resource that is built into Chef client itself, or you can say, take this cookbook or even a recipe within my cookbook and just run this cookbook on this remote machine. And so this is kind of, we're hoping by doing this that gives people kind of more confidence about getting started with Chef. Take an example of what a Chef resource might look like. It might be if you're managing users on a system, very contrived example. I'm full of contrived examples. User Stuart do action create end. That would be a very simple recipe in Chef, and that would sit inside a cookbook, and then you would take that cookbook ordinarily and run it on a server. You can take that resource from Chef and actually run it on a server by doing this chef run command. So chef run, specify WinRM, which is a protocol for communicating with Windows, username, password, and then you can say user, which is the resource within Chef, Stuart, which is the name property from the resource, and then a list of actions and other properties you want. So action equals create there is literally replicates that. We're going to get into demoing it pretty quickly, hopefully. But a couple of things first. So because we've got chocolatey kind of support inside, you might imagine then that you could take this resource, like chocolatey package notepad2 do action equals actions install, and that becomes this command line. Pretty simple so far. The thing to remember about Chef resources, of course, is that they are designed to be idempotent, so you can rerun them with the same inputs and you get the same output if the state of the system is the same. If the state of the system doesn't match the target state that you're trying to get to, the Chef resource code will bring it to the right state. And so this is hiding that complexity from you. And this is just a novel way of getting into it. So what's that got to do with Azure? So, or Azure. We've got Azure Cloud Shell. Who here is using Azure in their environments today? Okay, so about half, just over half the room. Are you familiar with Cloud Shell? Who's actually familiar with Cloud Shell? Okay, so you will find, for the rest of you, Cloud Shell is a container that runs inside Azure Container Instances that you access through the Azure portal. And it's been preloaded with the tools needed to administer and sort of create VMs and manage resource groups and deploy containers and so on within the Azure environment. So I'm going to jump out these slides. And go into Azure. And I'm going to make sure, just refresh this to make sure that we're connected. And so your route into Cloud Shell on Azure is like this. You press this button at the top, and up pops a window. Further down, it says requesting a Cloud Shell. And we actually get a terminal window onto a bash shell running inside an Ubuntu Linux container running in container instances that we've connected to. And this container gets rebuilt periodically. So we're working with Microsoft on the sort of timings of that. But in this container, we've got our AZ commands, and so this is the kind of traditional Azure CLI tool. You actually do get a choice of whether you want Bash or PowerShell at the top. It actually doesn't matter anymore because you can literally go into PowerShell core from within Cloud Shell and run PowerShell, and all your PowerShell commandlets for Azure run inside this Cloud Shell. Now, if I just come out of that a second. So the other thing about Cloud Shell is it mounts a cloud drive that it stores as an image in a storage account within your subscription. So every time you come back to it, you've actually got access to local storage. Your home directory is kind of available to you all the time in here. So the thing we've got is, if you're familiar with Chef DK, or you're running Chef in your environment, you will find all your Chef tools on your development workstation. Well, I don't need those tools on my development workstation anymore because they're all in Cloud Shell. So, for example, we've got Chef Run, which is the tool I mentioned a few moments ago. Hopefully. There we go. And Chef minus version would be like how we tell you to go and find out what version of Chef is installed. So this has got like slightly older Chef DK on it, built-in Chef clients, delivery tooling, a tool called Burke Shelf, which we use for dependency management, Kitchen, which we use Test Kitchen. Is anyone here using Test Kitchen in the process? Okay, good number of people. And Inspec, which is the CLI tool, which is our compliance solution. So what I've done is created a resource group called WinOps, because I'm full of great names, and created a virtual machine called WinOps 1, and it's just a Windows 20 machine, 2016 machine, that we can connect to over WinRM. And so I just wanted to demonstrate, first of all, that, in fact, I'm going to just go back up in my history, it's probably easier. So we can run Chef Run, WinRM, Azure at IP address with a password. And then we've got a user resource, user Stuart action equals create. And this will go off and run Chef Run for that resource. We'll go on, it says packaging a cookbook. What it's actually doing is writing a temporary cookbook with this user resource in it. It's building this thing called a policy file, which is our way of wrapping up all the dependencies that are required for that resource to run remotely. It's then transferring that policy file to the target. If Chef Client wasn't installed on that remote machine, it will install it. And then it invokes the Chef client remotely using the policy file to go and converge, which is our, what we call converging towards the target state. And then there we go. I've now got a user called Stuart on my remote system. So the other thing about Cloud Shell is that this is fine for kind of contrived examples, but you might want to work with kind of larger examples like cookbooks. And so those of you who remember your chef training would have gone something like this: chef generate repo, my repo, I'll call it WinOps, just to be neat and consistent. And this uses the chef tooling to go and create a structure that's required for holding cookbooks, and it's a structure that is supported by the chef server when you kind of upload your cookbooks to the chef server. Your ID, you'd use Visual Studio Code, or any Atom users. Yep. So, and if you use Visual Studio Code, you type code dot. Well, if you do that in this container, you actually get a browser which contains the Monaco source editor, which is what is actually inside Visual Studio Code. And it will open up the structure, that directory structure, on the system, give you the sort of code coloring, and you can actually work with these files. So we've got our default recipe here. And it's completely running in the browser, but nothing installed on my machine sort of required to do this. So now I can sort of take this default recipe, which is, again, contrived. Let's do a chocolatey package. Notepad 2. So now we can get into the realms of writing normal kind of chef. So this is how you would start writing a recipe within Chef. Chocolatey package 2, action install, whatever, and you can Control S, and it saves the file. So it's just like working with that folder within Visual Studio Code, but without the extensions just yet. And I'm hoping one day that we're going to see extensions running in here as well, which would be really sweet. So now if I cd into this cookbooks folder and go back to my chef run command, I can take this cookbook and execute it. So the way we do that is by just using the format we use for describing the cookbook and the recipe. So as this happens to be default.rb, I could just specify example, which is the name of my cookbook. To be more explicit about it, I put example default and run that. And then what this is doing is exactly the same process as before with that kind of single resource, but actually taking the whole cookbook and applying it. And of course, this cookbook is written in Ruby. So whilst I've got a very contrived example of chocolatey package up there, there could be some more complicated things that you want to do in recipes. I'm sure those of you who actually work with Chef for more than a day actually do more complicated things than just the contrived examples I've got here. And so now we've got states where we've taken that cookbook and executed it on the remote machine using Chef Run. But it's given us a base to work with that can then be taken and used with all the rest of our workflows. So we've got kind of configuration within here that allows you to use Test Kitchen, and you can directly upload this cookbook to your Chef server if you have your keys installed inside your container. So this is kind of the sort of installation part or the configuration part of the code. Kind of what about the compliance piece? How do we test that Notepad 2 has actually been installed on that machine? Because I'm just running in a Cloud Shell. I don't really want to go onto the server particularly to go and have a look at that. And so our tooling for that is a tool called inspec. And if I come in here and go, so inspec is installed again within this cloud, the Azure Cloud Shell, and it's a bit out of date, as you can see. But that doesn't affect what we'll do here. We can do inspec init profile. I'll give it a name test because I'm full of useful naming. And it tells you what it's doing. It goes, you can't quite see it, but that doesn't make it any better. It creates a new profile with a directory. The directory itself, if we refresh this, it comes up here. So an inspec profile folder contains an inspec YAML file, which is just a description of the profile. It just has like author naming and things like that in it. And a number of controls. So we've got our example.rb. And again, inspec is a DSL written in Ruby based on RSpec's language, if you're familiar with kind of the Ruby world. But ultimately, it's the same kind of mechanism. We're describing resources and their properties within a Ruby file. And so if I change this to WinOps and say, what should I say here? Describe package, Notepad 2, so this is like RSpec's language. This is kind of spec language. We have this construct called should, which is a way for it to describe what should be tested. And we have this thing called, this is B directory. We want B installed. And B installed is a thing called a matcher, and the matcher is kind of what we're trying to match. So exists is a matcher. So if you're testing a file, it should exist is kind of quite natural language to write. And obviously the benefit of just being able to describe your prerequisites and components of your application in code are that you can take the output of this and go and satisfy some auditor that the things are configured the way they should be. And we've seen it used kind of across teams to say, okay, this is what you told us you wanted from the system. We'll deliver this environment to you and give you this report to say, yeah, this is what's actually been installed. The wider use is for the sort of compliance aspect. So when you get into the sort of CIS world or the sort of PCI compliance worlds, where there is a description of steps and measures you can take on a system to configure it to a compliant state. And within our commercial product, we've codified that into a set of profiles that you can actually use. And so we've got CIS benchmarks for Windows and for different Linux distributions, for example, within our commercial product. Also, we have profiles for Azure resources themselves, and I'll kind of come on to that in a minute. But I'm going to kind of make this really simple. So this is just describe package Notepad 2, it should be installed. I'm going to kind of go up my history a bit. That's not the right thing. Let's go much further up my history. Okay, well, let's write it. Back. So inspec's command line is inspec exec test, and then we're -t for the target. Password stays the same. I think that's it. And so this is all still running within that container. And it says Notepad 2 should be installed, expect system package 2 is installed, and for some reason it is not. I can't remember what I did there. Did I actually? Busy package 2. Actually install. Let's just make sure I did actually run this. I'm pretty sure I did. But the idea is you can go and describe what your whole that set of targets looks like, and then go and verify them with inspec. So that covers inspec within the VM itself. But what about if you want to test the actual provisioning of machines within Azure? Well, we've got. I'm going to move on sort of from this whilst that's going on in the background. We have, if I come on GitHub, an inspec Azure resource pack. Now, resource packs can be included within profiles, and so from one inspec profile, you can depend on this resource pack for Azure resources, and this is how you kind of include it, just by adding this kind of depends name inspec Azure, and then a URL. It literally currently points to our GitHub location, but you can point it to file locations and so on if you've got something locally. And the whole point of this profile is that this library provides access to interrogate resources that are running within Azure using the same inspec description language that you use to describe resources that are inside the VM as well. So if I actually run this from my machine, this doesn't run currently on Azure Cloud Shell. We're waiting for the next refresh of the container image within Cloud Shell to allow this to work. But if you want to test whether a virtual machine in the resource group WinOps that has a name WinOps1 should exist, whether it has some the Microsoft monitoring agent installed inside it, and the type of resource that has been provisioned is Microsoft.compute virtual machines, then you can run this. And so, again, using inspec exec test, which is the profile name, and then instead of -t WinRM or -t SSH, you provide -t Azure and then your subscription ID for your Azure subscription. This will go off and communicate with the Azure API to go and detect what is running in your environment. So there's a management API that this is connecting to. It says not touching anything. Not locked up. Not normally that slow, which is awesome. The demo fairies are here today. There we go. Okay, so it connects to the management endpoint, and it goes and verifies the things you've asked for in the within that profile, the matches such as should exist. And then we give you some access into the properties of the resource via the API. So in this case, we're looking at things like approved extensions. And so you can use this to describe your provisioned infrastructure. So maybe you've got a dozen machines. They all need to be configured the same way. You can come in here and describe what they look like. You can instantly see which ones have been provisioned incorrectly. And there's obviously a tie-up into our commercial software as well. Using the commercial software, you can use this language. You can run these type of tests from our Chef Automate system as well. But it is open source, the kind of core library. So we've got some examples here. Verifying property of the Azure VM or like of a security group. We also can go and look at the Azure Graph API for Azure AD and go and look at users and their user properties. We've got resources that test whether, for example, someone changed the keys on your key vault within the last 90 days, which is kind of might be a common requirement if you're looking for CIS certification, that sort of thing. We've got those kind of resources, base resources in here. And we'd love you to contribute more if you're interested in that area. All right, I think I've done the thing. So what did we show? We showed Chef Workstation running in Cloud Shell. Hopefully gave you a glimpse of where we're trying to go with getting started with Chef and how we expect people to get started and actually get to the next level with their journey in the future. We ran some ad hoc tasks in the chef run command. Showed you the kind of classic Chef DK tools you're used to are there inside Cloud Shell. Code editor running inside Cloud Shell. We tested resources inside the VM with inspec, which I'll go and check. And finally, we showed about testing Azure resources with inspec. So this is the point. As everyone's been very quiet so far, you get to ask me anything for the next 5 minutes, and then after the next 5 minutes, we can take kind of any further questions out into the one-to-one area. It's Red Hat, Ubuntu, Windows. So the question was, what OSs does Chef Workstation support? And it's all the same as Chef DK today. So it's basically all the classic desktop Linuxes and Windows.
That Chef repo, is that a Git repo?
Yes, it is. Yeah, and you'll also see that if you're in Cloud Shell, you actually have access to Git tools within Cloud Shell as well. So yeah, because Chef Generate does actually use Git behind the scenes to go and initialize.
The Chef client, when you give a command to run it to run Chef run,
Yep.
it pushes to Chef client. Does Chef client support like a full model or?
So what actually happens?
Sorry, Stu, can you just repeat the question?
Yeah, I certainly will. So the question was, what happens when you've got a sort of target machine with no chef client? Is there a pull model on how to get the chef client there? What actually happens is, in your home folder, when you run chef run for the first time against a target machine that doesn't have chef clients installed, there's a Chef Workstation cache that actually gets populated with the client for the first time, because the thing we want to enable with Chef Run is that you might have 10 machines that might be called WinOps 1 to 10, and you can actually specify that on the command line, and it will expand. You can go WinOps square brackets 1.10, and it will go and execute against those machines. The way it's currently set up is that the MSI comes down to your local cache the first time, and then gets distributed from your local system to the machine over WinRM, and then the MSI is then executed to install the Chef client. There is in the roadmap a completely remote mechanism where we will instruct the remote machine to go and pull down the MSI individually from our CDN, which will be the default, or a location that you specify.
Interesting, interesting answer, but it's more, so if your clients are on a separate network that's locked down, do they, like you would be able to open ports or something, so you would be able to push information, but can they pull like the Chef server every once in a while, or say can they pull from somewhere to see if this is coming?
So yeah, you're talking about a more mature kind of Chef setup there, and which is our default mode. Yeah, so like ordinarily, someone would use Chef, and Chef would be already kind of in an image, probably that you may have created using a tool like Packer, if you're in the kind of virtualization world, and that would already have the first Chef client inside it, and then yeah, you can keep the whole of the Chef client kind of infrastructure and delivery within your own air gap if you really want to. Sorry, yeah.
Is it possible to integrate Chef Run on the Workstation bit with the, keep on say BSTS, but Azure Devops with the deployment pipelines?
Can we integrate Chef Run with Azure Devops? And the answer right now is no, but the answer, I don't think we will probably go that way specifically. We will actually want people to run Chef in Azure Devops. There is, on the marketplace, we've published a set of Chef tasks that run inside Azure pipelines already. They allow you to install and configure Chef. On the machine, you can install Chef DK. If our recommended way using Azure pipelines is to use a deployment group that deploys the Chef client. Those Chef clients will then talk to a Chef server that you push to. So Chef Run isn't involved in that transaction at all. We want you to get to the end game, which is you're running Chef client periodically on a system to manage the policy on the system. All right, I think we've just hit time correctly there.
Yeah, thank you very much for that. Really, really good some insights there. So thanks all. Any more questions for Stu? Is in the the shift room at the end of the corridor. And now it's lunchtime, so enjoy. Cheers. Thank you.